thanks for coming. So I'll try and do my quick spiel here in less than 5 minutes for Kylie. Yes, I come from Canada, the University of Guelph. It's cold up there right now, probably colder than here, but a lot of what I'll talk about today is bioclimatic design. So that's designing for the climate in mind, which is what David just taught us about, and we designed here based on lessons learned in the same climate zone in Spain. But I'm going to talk about mostly designing for extreme heat and how you design with hot temperatures, hot climates, and hot cities, and then prepare for it getting warmer. So we talk a lot about climate change and climate variability globally. I'm going to take it down to the street level and talk about microclimatic design in urban areas. And this is actually a picture that I took in Seoul, Korea this summer. And we can look at urban areas very differently, whether we're focused on an urban canyon or an urban forest or somewhere in the middle or a courtyard, like David was just showing us. So the classic urban heat island, which hopefully many people have heard of, but if not, it's the increased temperatures in urban areas as compared to rural areas. This is your classic shape. And we can get variations between suburbia, park, residential, downtown. Generally, people see it as it's hotter in urban areas than a rural area. All right, that tells us a very broad picture of the story, but the classic urban heat island is not what I'm necessarily interested in looking at. I'm interested in getting deeper into within the urban heat island, what are the variations, and this is how my artwork goes. These are my squiggles to show inter-urban variability of temperature, and that it's going to vary throughout an urban area. What else we see is that as the temperatures are rising, we're going to see increasing extremes within those already extreme areas. And on top of that, there's inequalities in the social resources that we use to mitigate heat or the people that receive those resources. So for example, air conditioning and socioeconomics that influences who's going to suffer from extreme heat, which is actually the leading cause of death due to weather in this country. So I'm interested in then looking at within these spaces, what makes a space cooler, what makes a space hotter, and how can we focus on these spaces that are so hot, requiring so much more energy in hot areas in the summer season, and bringing that peak down. Because if we have a 2 degrees, or if we have a 5 degrees warming here, but it's less 8 degrees Celsius cooler here, how can we take lessons from here and apply it here? And that's bioclimatic urban design, essentially. But there's a lot of biophysical processes going on. So key questions here is how can we improve measurements within urban areas, not using an airport station, but using measurements in an urban area to create targeted solutions for some of those issues. And then what role does urban design play in climate mitigation and adaptation? So first question, it's really important to be getting finer scale data. We can't use that larger urban heat island dome and then take that information and try and get targeted solutions within an urban area. But we can have finer air temperature information, radiation, remote sensing is getting really good at this as well. Then we can provide the appropriate design recommendations to people like David and work together to create these really nice spaces that are not only nice looking, but also thermally comfortable in the way that people will use them and they're safe, so they're not going to be causing higher temperatures. And energy use is important as well. So within an urban area, one of the most important contributors to the urban heat island is the radiation. What's being absorbed, what's being emitted, what's causing those temperatures to go up? Because that use of impermeable surfaces, such as the 94% impermeable surface in downtown Lubbock, is what absorbs all the heat and re-radiates it as long-wave energy that we feel as hot, right? If you're using cooler surfaces, such as vegetated surfaces, water, parks, shade, then that doesn't radiate heat as much as using it for other forms of transformation to latent heat. And then I wanted to quickly mention how we look at a human in one of these environments is rear cylinders. And so there are all these different radiant fluxes on a human that we're interested in understanding and how that connects with health and how that connects with urban design and where is it going to be shaded, where is it not going to be shaded. And so these are all pieces of information that can help us try and do these targeted interventions with landscape architects. getting urban stations like this up more within urban areas and understanding what a surface like artificial turf does to the heat balance or does to heat stress of a human, or you can put it over kind of any station, but getting more information at finer scales really helps us with this. And then even infrared. So this is an infrared picture taken of a playground. This is actually a tree here, it's hard to see. And then this is concrete and asphalt. And so you can see just what the changes in design can do for heating. And then obviously over airborne remote sensing helps with that too. And then finally, what role does urban design have in climate mitigation? So compare what a park cooling island can do. And this is a decrease of about, I think we found about 5 or 6 degrees Celsius. This is data we collected in Toronto in parks. So we took a bike through with all this instruments on the bike. And if we can get a cooling from a park cooling island of 5 degrees Celsius, then that 2 degrees Celsius we might see in 50 or 100 years from climate change and warming doesn't matter as much. It's important, obviously, but if we can start doing targeted adaptation interventions within urban areas to bring the temperatures down naturally, that's adaptation. And then you have mitigation, which is, yes, let's stop producing the climate change. So a mitigation example is then taking this, we decrease, if we have higher air temperatures in urban areas, that increases the use of air conditioning, that increases the air conditioning output from the air conditioners, and then that increases air temperature. It's a positive feedback loop. But we can go the opposite and decrease the air temperature, decrease air conditioning, decrease the energy use that's needed. So that's just an example of mitigation with climate change, but you have to have them both hand in hand to solve some of these problems. So that is my spiel, and hopefully we can discuss it after.